Alright, so what we're going to talk about right now is how to factor out the common factor. This is chapter 10.1. This is the most basic technique for factoring, and it recognizes the use of the greatest common factor, or GCF, between two or more expressions. The greatest common factor is the largest factor that goes in evenly to both expressions. So, for example, the greatest common factor of 2x and 4xy is 2x, because 2x goes evenly into 2x, perfectly in fact, and 2x goes into 4xy because the 2 goes into the 4, and you have the x in that term as well. I'm going to do an example or 3 here that shows you how you can factor a polynomial. So in this example, we have 3x and 12, or 3x plus 12. So what that is 3 x's, or 3 times x, and 12. So if you think about what goes into 12, you have a 3 times 4, or you could do times 2 times 2 if you wanted to bring it all the way down to its primes. And you can see that there's a 3 in the first term and a 3 in the second term. So the greatest common factor in both terms is 3. And so if we were to factor this polynomial, we are going to take the 3 out and rewrite it with what's left. So what's left in the first term is the x. What's left in the second term is the 2 and the 2, or the 4. There's another way to visualize this, and I like this other method quite a lot, and that is to put the 3x and 12 into an area box model and understand the idea of multiplication of length and width to be the area. So you got to think, what's the number that they had in common? The 3. And what are the things that are missing in order to make the 3x? In that case, it's just an x. 3 times what makes 12? The 4. So this area box model also gives you the same answer, different process. Regardless, the answer is 3 times the quantity x plus 4. We would also say 3 parentheses x plus 4. Either way. Okay, so that's for the first one. I'm going to do 2 more examples. And I'll be modeling it in both ways. So in this one, we have 3 times x to the 8th plus 3 times, I could write it as 3 times 5, x to the 3rd plus 3 times, I'm going to keep it as 4, x squared. And I can see that the 3 is a part of my greatest common factor. This one's a little bit more tricky because there's a 3 in common in each term, but also you'll see that there's some x's. The first term has 8 of them, and the second term has 3, and the third term has 2, so we can take a total of 2 x's out of each of the terms. The greatest common factor goes outside of the parenthesis, and then we'll write what's remaining inside. And I'm going to visualize it as an area box model as well, because that might be a way that really works for some folks. So 3x squared was taken out. So what is needed in order to make 3x to the 8th? 6 more x's, so x to the 6th. 3 times what makes 15? That's the 5. We have 2 x's, we need 1 more x. Then 3 times what makes 12? 4. And we don't need any x's with that one. Or if you're doing the method over here, you have taken a 3 out and you've taken 2 x's out. What's remaining is x to the 6th. You've taken the 3 out. What's remaining? The 5. You've taken 2 x's out. 1 x is left. Same thing here. The only thing left is the 4. You took the 2 x's out and the 3 out. Okay, with this last one, I'm just going to do the area method. 3x y squared, 120 xw, 12x squared. What's in common in each? We have a 3 that can go into everything. And I'm looking to see what else that we have. Each of the terms has an x. So we can take an x. The first term has a y, but the other ones don't have a y, so we can't take a y out. Same with the w, so just 3x. So what do we need here? We need the y squared. 3 times what makes 120? Good question. It looks like 40. And we still need the w, so 40w. 3 times 4 made the 12. And we still have an x. All right, and so with this one, 3x was our greatest common factor. And we're going to factor our polynomial by rewriting it. There you go. Okay, so after these 3 examples, I would like for you to try independently these next 3. You're going to be reviewing your answers to these in class. So what I want you to do is try these yourself. If you struggle and you end up getting the wrong answer, that's okay. But I do want you to come to class with your work done for these so that we can talk about where you are in this process. All right, and I will point out that example 2 might be the easiest one for you to start with. And example 2 is a lot like our first one that we did together just now. So if you're struggling, start in the middle with that example and then maybe move to 1. Start with 1 if you'd like, but example 2 will be slightly easier. And then in class, in groups, we're going to be looking at this 3rd example that you've done, and I'm going to ask that your groups illustrate it as a rectangle. And you do not have to do that before class. So if you could have the first 3 done, and then in class we will do that last bit together.